Hi, and welcome to this K-12 International Academy Flipped Instructional Session. This is Middle School Earth Science, Semester A. Today's topic is Lesson 2.12, Metamorphic Rocks, and I am Mrs. Fessel. In this flipped lesson, we'll be learning about metamorphic rocks. So your goal is to watch this recording before the Class Connect session, the live Class Connect session. Look for the flipped follow-up on your Class Connect schedule. Our goals for today are to be able to explain how a metamorphic rock is formed, and also to give examples of metamorphic rocks and to describe how they are formed. So if you want to take a look at some metamorphic rocks, some of these listed are actually sedimentary rocks, but we're going to talk about how sedimentary rocks can turn into metamorphic rocks. So imagine rocks compressed down to a fraction of their original size, changing from one form to another. Evidence indicates it really happens, even though it takes a long time and can involve enormous forces and the heat energy deep within the earth. For example, at first glance, rocks that make up patios or pathways may appear to be made of shale, a sedimentary rock, but they're actually made of a similar rock called slate, which is a metamorphic rock. Because it breaks easily into sheets and comes in a variety of colors, slate is often used for roofing tiles or flagstone walkways. So when you look at these two rocks, shale, a sedimentary rock, and slate, a metamorphic rock, at first they do look very similar. But what happens is shale is placed under pressure for a long period of time, pressure and heat, and it metamorphosizes or changes into slate. So that's where the name metamorphic rock comes from, change, a metamorphosis. Rocks that undergo change without melting are called metamorphic rock, because if it melts, then you would have magma, and that would form an igneous rock. So it has to go the rock has to undergo great heat and pressure, but not melt. Another common metamorphic rock is marble. You may have seen it at a museum because it's often used to create statues and sculptures. It's often also used in architecture. Marble is a very hard rock that does not crumble easily and lasts for hundreds, even thousands of years, such as many well-known Greek and Roman sculptures. One such statue is Artemis of Versailles at the Louvre Museum in Paris, France. Another example of a sedimentary rock turning into a metamorphic rock is limestone turning into marble. Both have the same chemical composition by containing the mineral calcite, calcium carbonate. If you were to place a few drops of acid on marble or limestone, you'd see fizzing. That's because they're both made of the same chemical compound. But limestone, once placed under great heat and pressure, turns into marble. So the traits of metamorphic rock depend on the temperature and pressure that the rock was subjected to when it formed, as well as what original rock it came from, such as shale or limestone. Any igneous or sedimentary rock may be changed by heat and pressure, often with involvement from dissolved chemicals or gases. We're going to talk about how. So heat energy and pressure compress the rock. They squeeze it together. That drives out any water or gases, which causes a change in the rock structure as the water and gas leave. The water and gas may contain molecules that combine or react with the original rock. Large crystals may grow, new minerals may be produced, and layering or flakiness may develop. So this is a little small, but you can see slate is here. As it undergoes more heat and pressure, it becomes a different rock, then it becomes schist, and then it becomes gneiss as this same rock undergoes more heat and pressure. One of the most famous metamorphic rocks is diamond. Diamond actually forms from coal, a type of hard coal called anthracite, which forms when the soft bitmus coal metamorphosizes. When hard coal is metamorphosized, graphite is formed. Graphite may then even further metamorphosize into diamond. So coal, the more heat and pressure it undergoes, the deeper it gets into the earth, the more likely it is that diamond will form. So there are two types of metamorphic rock, foliated and non-foliated. So here we have two types of rock. Gneiss, which starts with a G but is pronounced with a silent G. Gneiss, sample 2, and quartzite, sample 29, are both metamorphic rock. Gneiss appears layered, while quartzite does not. Gneiss, like slate and schist, which we've talked about, is foliated. Foliated means it has layers and will split into sheets when broken. Non-foliated rocks, such as quartzite and marble, do not split into sheets. You are not going to see layers in these rocks. Temperature, pressure, and what the original type of rock was determine whether a metamorphic rock will be foliated or non-foliated. So here's a few more examples of rock that can change into other types of rock. Sandstone, which is a sedimentary rock, can become quartzite. All those little sand particles are changed into small crystals. Shale, as we talked about at the beginning, becomes slate, and limestone can become marble. So that's our lesson on metamorphic rock. I hope to see you in the live session to carry this topic into further practice. Look for the flipped follow-up session in your Class Connect schedule. Attend a help lab if you need any extra support, and have fun learning. Thank you. Have a great day.